Okay, so we're coming to the part where if you are asked to find LCM. So again, what does LCM stand for? It stands for the lowest common multiple. Okay, so maybe you might not have an understanding of this yet. So what are called multiple? So for example, multiple. So like 24. So what are the multiple? This will be the multiple. So 24, I added another 24. I keep adding 24. Okay, that will be what we call the multiple. So I keep adding 24. So these are called the multiples. So I will keep adding 24. So these are called the multiples of 24. So if you keep adding the numbers, you are getting the multiples. Okay, but I would like the common multiple. So there's another number here. So yeah, if I keep adding 90, these are the numbers. So this is called the multiples of 90. But I want to find a common number between the two of them. I want to find a common number between two of them. Again, there are two methods. The generic one will be prime factorization. So again, if you are doing prime factorization, you got to do the ladder method first. So I presume you either do your ladder method or your branch method. So whatever is it at the end of it, you should get it in the index format. Okay, so so after this, I'm going to put them into groups to compare. I'm going to put them into groups to compare. And when I put them into groups, you realize that I'm writing them a little bit spaced out. And this time around, okay, I'm going to put them in the family, same family, but I'm taking the higher power. So you take the higher power, or what we call the higher index in each family. Okay, so between these two, okay, let's see. So index 3 and index 1, 3 is higher. Index 1 and index 2 is higher. So there is nothing here. So apparently this is the bigger index. So you take the bigger index and then you punch calculator. You realize that this is the lowest common multiple. So what do we mean by lowest common multiple? So actually, if I'm patient a little bit, right? If I go on a little bit more, if I go on this part a little bit more, I get 168. I get 192. I keep adding. Okay, I keep adding, right? Until I get a common number. So, okay, it's a bit messy. So this part are the multiples of 24. So this part are the multiples of 24. And if you compare to this part, this is the first number. 360 is the first number when the two of them are common. So this is the smallest common number between them. So that's why we call it the lowest common multiple. Okay, so it's very similar to HCF. The method is the same, except that in HCF, you take the lower power. In LCM, you actually take the higher power, which is the higher index. But you realize that everything relies on the prime factorization. The next method is called the repeated division, which is like the same thing. You can keep dividing. So you create a big ladder. So now I got 3 numbers. I need to find the common multiples. So it's very tedious if I'm going to do all the multiples. So it's going to be very tedious if I'm going to be doing this. So it's going to be very tedious if I'm going to be doing this, because the number will get quite big. So it's going to be very tedious if I'm going to list out everything and then I find the common one, the first common number. So of course, we're not going to go through the lengthy method. You don't have the time for lengthy method. So what you do will be you create a big ladder. Again, you think about your prime number. So you think about prime numbers. So can it be divided by 2? Can all the 3 numbers be divided by 2? So in this case, cannot. So I can try dividing by 3, and all of them can be divided by 3. Okay, then what is the next common number? Okay, I think they can be divided by 7. Okay, for highest common factor, you will actually stop here already because you couldn't go on anymore. But for LCM, right, you continue. You continue until everything become a 1. You continue until everything become a 1. This will be your lowest common multiple. If you realize, I try to arrange smallest to the biggest. So the lowest common multiple is 315. Okay. Sometimes they will tell you leave your answer in index notation. So if they tell you to leave your answer in index notation, means you don't press up calculator. You leave it in this way, in the prime factorization format. Okay, so this one looks easier, am I right? So most people will tell me that, hey, this one looks easier. But like I say, the prime factorization should be the method that you should try. Okay, so for these 3 numbers, can I try the method, the prime factorization method? Okay, so I'm going to try the prime factorization method. It should still give me the same answer. Okay, so I'm going to try the prime factorization method. It's a bit troublesome because there are 3 numbers, right? So some of you might feel that this one is so troublesome. I got to do 3 letters. Yes, you need to do 3 letters, but it's not as bad as you think. So you continue. So either you do your ladder or you do your branch out. So the idea here is you get the prime factorization. and your job is to compare them. Okay, after you do out the prime factorization, your job is to compare. So I'm trying to write in such a way that I can put compare in the same family. So do you remember what are you comparing? You are comparing for the higher index. So you're comparing for the higher index. So in this family, right, this should be the higher index already. So all these are index 1. So these are the higher index. So if you punch out calculator, you also get 315. So even though the prime factorization method looks a little bit longer, but this will be the method that is preferred because it's going to help you with very, very difficult questions. Okay, so 2 methods for LCM, 2 methods for two methods for HCF. Okay, just now this one I forgot to write 360. Okay, so review the methods and make sure you can remember the methods.